This week you're going to be working on linear terms. This builds upon what we did last week with our 2D and 3D shapes. As you see over on the side, you have a little sampler. We're going to talk about points, lines, segments, rays, and then 3 types of line relationships. The first thing that's important to know is when we're talking about linear terms, things that have to do with lines, we're staying in the geometric plane, which is a flat, continuous surface. You might want to try to envision a whiteboard or your laptop screen or some other flat surface. This goes with our 2-dimensional shapes from last week when we used plane geometry terms, such as triangle, pentagon, quadrilateral, and hexagon, and so forth. We are not talking about anything that has any depth to it, so you don't want to think about any of our 3D shapes from last week. The first figure that we're going to talk about is a point. A point is an exact position in space or on a line, or any other linear figure. You have 3 points in this image. You have point N, point A, and point Z. In geometric notation, there's no specific way to write the name of a point other than the word point followed by the letter that goes with the dot. A point looks like a dot, and the letter is its name. If you look at these 3 figures, which is not a point? The next thing we're going to talk about is a line. A line is a straight path of points that extends forever in both directions. We use arrows on the end to signify that that line virtually extends infinitely. So even though we can't see it because your eyeball is not going to travel forever, the line will do that. And we say that it does it virtually. It also means it does that with your imagination. A line can have an infinite number of points on it. In this image, you'll see there are 4 points. Whenever you see a line that has points on it, we name it with the 2 furthest points, meaning they're closest to the arrows. So we have point C, point V, point P, and point X. Point C is all the way over here on the left, and point X is all the way over here on the right. Those are the 2 points that I'm going to use to name this line. So if I'm just naming it, I would say line CX. In geometric notation, however, you have a symbol. So this is a little bit different than what we just had with the point. You have a symbol where you would have a line with 2 arrows over the letters C and X. Because the line has arrows on both ends, you could actually reverse the name of it. So if you wanted, you could also call it line XC. You could also reverse in the geometric notation, and you could have those letters reversed, where you would have the line on top, and then it could be XC on the bottom. If you look at the line here, what should I name it? The next figure that we're going to discuss is a line segment. A line segment is a section of line that ends in 2 distinct endpoints. They are usually named. It also has a midpoint. Its midpoint is halfway between the endpoints. So I'm going to look at this line segment in the middle here. I have a point at this left end, point S, and I have a point at the right end, point K. The reason that we have points at the very terminal end of the segment is because that's where it stops. The word segment means a short section of something. You might be familiar with TV shows that have segments. Things like Saturday Night Live or Robot Chicken are divided into short segments, meaning scenes that are not connected to one another. So a line segment is just a piece of a line. It's not connected to the rest of the line. If you look at this top segment here, you'll see that the points at the ends are squares. Sometimes the end points can be in different shapes. If you look at the third segment in the image, you'll see that there are vertical end marks. In measurement and blueprints, you'll see this much more often. When we name a line segment, you'll use the endpoints to name it. So we'll name it line segment SK. In our geometric notation, you have a segment with no end symbols, and then S and K are used to name it. You could also reverse it because both ends are terminal, meaning both actually do end. So you could call it segment KS as well. If you look at this segment, what should I name it? Our next figure is a ray. A ray is a line that has one endpoint. The other end goes on forever. It is infinite. So a ray has a beginning point. You should think of it similarly to a ray of light. It begins at a source and then it travels forever in one direction. However, you will have multiple points along a ray. So over here on the left, you have point A. And then further along in the direction that my ray is traveling, because I do see an arrow signifying the direction, I do see over here, more towards the right, point B. I can only ever name a ray starting at the point. So when I name this, this is ray AB. In my geometric notation, I'm always going to draw an arrow pointing towards the right, and the point with the letter at the point goes first. Then the point furthest along my ray is the other point for its name. So this is ray AB. I can never reverse it. What is the name of this ray? Now we're going to talk about line relationships. There are three types of line relationships that we're going to discuss. The first is parallel. Parallel lines are two lines in the same plane. And remember, we said that means on the same flat surface. These parallel lines will never cross. They're traveling in the same direction at the same angle. So over here on the left, let's look at lines 1 and 2. You see that they're both vertical lines. They're in the same plane, they're on the same flat surface, and even though I can't really see it, we know that these arrows mean they extend forever. And if I were to follow those arrows, the lines will never, ever, ever touch. That makes them parallel. If I look over here, I have line AD and line HK. These as well are in the same plane, traveling at the same angle, and will never cross over one another. They will never touch. That makes them parallel. Something that I like to remind students when they're talking about parallel lines, and if they're having trouble remembering, is that the word parallel has two L's next to each other that actually show you what parallel lines look like. So that's a good giveaway if you're having trouble remembering what type of line is what. Parallel shows you two lines that don't cross. The next relationship is an intersection. An intersection is a linear figure that crosses something at a specific point. So I have three different images in here. I have intersecting lines, and this is line GU, which intersects line MY. They have a point of intersection. That's exactly where they cross. That point of intersection is point T. Over here in the top right, I have line QE crossing line LF, and that's the point of intersection here, point W. It doesn't matter what angle they're crossing at. The fact that they're crossing means it's an intersection. You should think of driving. Not every street comes to a really nice, even intersection. Sometimes there are sharp intersections where it's hard to see. Sometimes you might even have a roundabout or traffic circle. So that brings me to the third image on this page. You have a line that's crossing a circle. That's okay, and that's still an intersection because a line is traveling over another figure. So anytime a line or a segment or a ray crosses over another object in the plane, we're going to call that an intersection. The third relationship is very particular. There's only one angle it can ever cross over at. Our perpendicular lines must intersect at 90 degrees. Because you are in building trades and building services, this is something that you need to know for your shop. This is something that works on the concept of plumb, level, and square. If something is square, it is 90 degrees. These perpendicular lines are intersecting at a square intersection. In fact, I can take an object that's a square and put it at the intersection to test it. You've probably done this in your framing unit with a framing square or a T-square. So if I look at this image over here on the left, I can see that line AB is perpendicular to line DC or line CD. It's the same thing because you could reverse it. So perpendicular lines intersect at a right angle, which is 90 degrees. Take a look at this image. These are a bunch of train tracks, and some of them intersect, some of them are perpendicular, and some of them are parallel. I want you to look at the yellow lines. How would you describe them? Are they intersecting? Are they parallel? Or are they perpendicular? Now take a look at the red lines. How would you describe them? Are they intersecting, parallel, or perpendicular? Nice job. This was a good warm-up to start off the week. Have a great day.